I did all three of my co-op rotations at a place called Silfex in Eaton, Ohio. We produce silicon parts that go into etching chambers to make silicon microchips. My first position there was crystal growth R&D. In doing so, I did a lot of material analysis on the parts we were producing to see if they met specification. And when they didn't, I would try to investigate why. If it was our growth times, our cycle times, our changes in the recipe in any way to see if those were reasons why the parts were out of specification. I also did a lot of research and learned a lot about growing multicrystal and single crystal silicon. The second cooperation I did there was in inner value stream. And this I did a lot more hands-on work on the machines that machine our parts. So one of the things I did there is I qualified quite a few machines in order to improve production. I also updated a lot of their processes through engineering changes to produce better quality parts and in shorter times. I did a lot of engineering documentation changes and just created new documentation. For example, I created some documentation for certain processes in terms of like cleaning parts on machines, stuff of that nature. There was also a project that I worked on to see if there was a correlation between a machine coming out of calibration and our parts being out of specification. So during my time there, we created a completely new plant, or we were in the process of building a new plant. And some of our parts continuously kept coming out of specification. And we weren't entirely sure if it was machine related or if it was operator error, because most, if not all, the operators there were pretty much new. So one of the things I did was I investigated the ball bar calibration on machines. There was a weekly measurement, and I would look at all the measurements of the ball bar on all the machines and try to relate it back to see if there was a correlation between that and parts coming out of specification. Turns out that they didn't really have an impact, and that the parts coming out of specification were just likely operator error. My third rotation, I worked in lapping and polish process engineering. I spent most of my time in lapping, but I did learn a decent bit about polishing. So during my time there, I actually learned how to run a lapper, and I conducted a DOE to try to optimize the settings of the lapper to produce a tighter distribution between the thicknesses of the parts. So we ran 5 discs of silicon at a time, and through working with the machine and through doing the DOE, I was able to optimize the parts and get a tighter distribution between thicknesses. I also worked with large sets of data to find historical trends and allocate those to financial losses through some part families and certain processes. I did this both for lapping and for shaping. One of the projects I worked on was to investigate an entire flow of a part and see where the issue stemmed from that we were seeing. Because we were seeing flatness issues on parts coming into lapping and then out of lapping as well. So originally I was going to try to create a recipe in lapping to fix the flatness issues. But through our investigation, we determined that the measurement tools that we used for flatness were wildly inaccurate. We had roughly 3, and they weren't very accurate to measure flatness. So I had to work with metrology to research new measurement tools and implement a cost savings analysis to show and advocate why we need a new tool. So I did that, and I also created benchmarking data for all of lapping, which included doing CPK values, first pass yield on various different parts, defects seen throughout different parts, and what parts were the higher runners and what defects were shown most frequently on those parts. I also did some analysis on operator performance. So yeah, those were my 3 rotations at Silfex.